where we started as servicing people like companies like TCS, Infosys, all these companies were mainly to service. And today, the focus is on a developing product. For example, we have a company called Zoho that has got a product called Zoho Books. Software that's finding wide acceptance across the world. I've actually comes report these offerings and programs. A software that's going to be, I believe, the software that's going to take the world by storm. Accounting, it's one of the best software in the world. That's where the GCC comes to play a role. So, India is attracting a lot of countries, a lot of companies, and a lot of GCCs are being established in India. Even in Coimbatore, we have GCCs. இதுக்கெல்லாம் ரீசன் என்னன்னா விசை மேக்ஸ் இஸ் தி பேக்போன் ஆஃப் ஆல் சப்ஜெக்ட்ஸ் அப்படின்னு சொல்லுவோம். கேள்விப்பட்டிருப்பீங்க. எல்லா பாடங்களும் முதுகெலும்பு கணிதம் அப்படின்னு சொல்லி நான் படிச்சிருக்கேன். ஸோ வித்வுட் மேக்ஸ் வி டோன்ட் ஹேவ் திஸ் வேர்ல்ட். வெரி சிம்பிள். My BC work was related to image processing. But I still remember my guide, happened to be professor at Gandhigam University, telling me that when you take MRI images, MRI scan, when you take an MRI image, you get only slices of images. And we get a whole image. The image it becomes a whole image. But actually, it's in slices. So we use numerical methods, we interpolate, and we get the whole image. I was astonished. I where does it apply? It comes in the image processing, it comes in images. So if you name any area, definitely you'll find the mathematics there. In the area of maths, if you take data sciences, it's nothing but statistics. Regression analysis, statistics. So whatever subject you have, you'll find the maths playing a crucial role there. So you're all very lucky to be under the holder, the department of maths. Maths have got a very, very bright future. And when I research work, image projects, it involves maths. There are maths in my work. I think commerce and SPSS package use model develop that's maths. Fuzzy logic, fuzzy logic, we say threshold value or value. See, binary. So binary, digital world, analog world, very simple and different than analog world. Threshold value can be changed. See, analog is something that will accept mistakes. Digital world is something where we never accept mistakes. It will be either 0 or 1, pass or fail. Teachers paper கொடுக்குறாங்க இல்லையா, 37 மார்க் வந்து நம்ம 24 பண்றாங்க இல்லையா, தட் இஸ் அனலாக். இது கம்ப்யூட்டர் தெரிஞ்சீங்கன்னா 37 தான், ஸ்டூடெண்ட் ஃபெயில். தட்ஸ் டிஜிட்டல். விச் இஸ் பெட்டர்னு யோசிச்சு பாருங்க, சொல்லுங்க. விச் இஸ் பெட்டர்? Analog is better. Actually, quality of sound, reproduction of sound is better in analog than in digital. நம்ம வீட்டில் டிஷாண்டர் வச்சிருக்கோம் இல்லையா, சின்ன டிஷ் இருக்கு இல்லையா, இட்ஸ் ஆக்சுவலி டிஜிட்டல். இட் யூஸ் டிஜிட்டல் சிக்னல்ஸ். டிஷ் கொஞ்சம் லைட்டாக டர்ன் ஆனாலும் சிக்னல் கிடைக்காது. பழைய காலத்தில் பெரிய டிஷ் இருக்கும், ரொம்ப ரேர் அது பார்க்குறது. அந்த டிஷ் பார்த்தீங்கன்னா கொஞ்சம் டைரக்ஷன் மாறினாலும் இருக்கு எடிக் சிக்னல். நல்லா இருக்கும், சரியா? You should all be like analog signals. Partial information correct, you'll have to bring systems which will help you to be successful in life. Never be digital. And computer science field, I always believe don't believe in computer. Computer promotion and I didn't solve the video. So yeah, computer didn't fail and backup that will be where our system come in play. That is why you all students can play a very, very important role. மனசு வச்சுங்க, மேக்ஸ் நல்லா படிங்க. இதே டிப்ளமோ படிச்சு கோவிந்தராஜன் அப்படின்னு சொல்லிட்டு எங்க பேச்சுலர் பிஎஸ்சி நான் பிசிக்ஸ் படிக்கும் மேக்ஸ் படிச்சாரு 85 இது யூஎஸ்ஐ அமெரிக்கால இருக்காரு. எனக்கு தெரியும் ஒருத்தர் தான், இப்போ நிறைய இருப்பாங்க. ஸோ அவரும் இதே காலேஜ் தான் படிச்சாரு. அவர் கூட படிச்சு இதே காலேஜ் தான் படிச்சாங்க. கூட படிச்சு ஜீவா கவர்மெண்ட் கார்டு டிரான்ஸ்போர்ட் கார்டு இருக்காங்க. எல்லாத்துக்கும் ஒரே டீச்சர்ஸ் தான். But one is able to reach America, another is not able to reach USA. It is still employed in Gobi. Reason is that's where attitude comes in. Now the right attitude. Correct attitude or இருந்து பாருங்க, கண்டிப்பா நீங்க வாழ்க்கையில ஜெயிக்கலாம்.
welcome. We request our principal sir to honor our chief guest, Dr. B. Vithukkumar sir, with a shout. We request our HOD sir to present the memento to our chief guest.
So, it's our discussion to welcome Dr. B. Vithukkumar sir with us today to deliver the inaugural address.
Most necessarily Sundays and other faculties of the Department of Mathematics, Physics and Science, and my dear students. So good morning to all of you. I'm very happy. It is my privilege to stand before you because once in a time I was also sitting in your chair in this institution to attend this kind of functions. But those days we cannot have this kind of facilities. First of all, like computer facilities and other facilities are very meager. But even though we are depending on the library, books, and our beloved teachers, what they are teaching us, so it is a big motivation. I can able to remember, but my teachers are now retired. So if I say that, so the names are you are not hearing in this department. So anyway, so we are fortunate to have this kind of institution in this place to motivate many of our rural background, particularly like me as a first generation student. So there are many students are from first generation degree holders. So they are doing hard work. They have to develop their skills in the subject of mathematics or any other science or humanities. So this kind of institution will give a great support for a student community to enrich their knowledge to serve the society in what way you are going to learn. So you can take a subject of our mathematics. So there are a lot of opportunities. As like our principals are saying that we have plenty of opportunities in a variety of fields. So either you can choose competitive exams, or you can go industrial, or you can choose a Bachelor of Education, teaching, or you have to go for higher education like research and other positions. So there are plenty of opportunities there. A best example is we people are coming for the teaching society. We had a nice opportunity, as like our principal said, saying that the application of mathematics, but not only in image processing. So there are a lot of applications. Even today's workshop theme is mathematical modeling and differential equations. So differential equations itself is a applied subject. Other than that, analysis, algebra, complex functional topology. So we had plenty of application subjects. So one of the best subject is differential equation. Why we have to select mathematical modeling in differential equation is the world is changing well, right? So if you find any unchanged item, so definitely it will disappear in a certain time period. But if any item that will be changed with respect to time, so that means, for example, a model of a mobile phone. So model of a mobile phone, yeah, before 10 years you cannot see now. So now the model of mobile phone is something different. We had new features, new technology, everything in new. We cannot adopt the old one. So the change is everyone likes to change. So the changing is model as any quantity with respect to change in time is model as a differential equation. So in our lecture we can see many ideas about this mathematical modeling and differential equation with its applications. So hope this international workshop on mathematical modeling and differential equation will all of you will give a for insightful knowledge on this field So definitely this will create some motivation for your future SMS study or in your career. So I hope all of you are going to enjoy this today's workshop with meaningful knowledge. Thank you for this opportunity, for inviting me and giving a chance to interact with you. Thank you all.
Thank you, sir, for being an integral part of our workshop. Gratitude unlocks the fullness of life. As a valued member of our team, we invite Dr. S. Kavita ma'am to express gratitude through a vote of thanks.
Morning to everyone. As we conclude this inaugural session, I take this opportunity to thank everyone who made this workshop possible. First, on behalf of the organizing committee, I would like to express my sincere gratitude to our chief guest, Dr. P. Muthukumar, for agreeing to deliver the talk and gracing this function with a valuable inaugural address. Thank you, sir. I also extend my thanks to our distinguished speakers, Dr. P. Prakash and Dr. S. Jafar Ali, for accepting our invitation with a busy schedule. Thank you, sir. I express my deep sense of gratitude to our President, Secretary, Academic Dean and Administrative Dean for their constant support and encouragement. I sincerely thank our Principal for your presence and encouraging words. Thank you, sir. I also thank the technical team for their coordination and help. I express my heartfelt thanks to our HOD, all the faculty for their continuous guidance and support throughout the process. Finally, I would like to thank our students and participants from other colleges and universities. Without your participation, this workshop would not have been possible. Thank you, Madam.
Thank you, ma'am, for your articulate and heartfelt vote of thanks. Life is like a cup of tea. It's all about the way to brew it. Have a tea and be here on time. Let, let's take a short break. Please turn sharp and ready at 10:35 a.m.
Okay.
Hello? Yeah, bye. One bye. Hello? Bye. Tea time on bye. One bye. Ah, that's all. Ayo, kalian mulai bergerak. Iya, santai sedikit. Ah, bergerak. Belum senang. Itu, taruh deh.
The strength of team is each individual
It is my great honor and privilege to stand before you today as we gather for this prestigious international workshop on mathematical modeling and differential equations. On behalf of the PG and Research Department of Mathematics, Gobi Arts and Science College, I extend a warm and heartfelt welcome to each one of you. On this distinguished occasion, it's my privilege to introduce our chief guest, Dr. P. Muthukumar sir, who has graciously accepted our invitation to be a part of this workshop. Dr. P. Muthukumar sir is an associate professor in the Department of Mathematics at Gandhigram Rural Institute. He is an eminent academician and a highly respected scholar in the field of mathematics. With an esteemed academic career spanning 16 years in teaching and 13 years in research, he has made remarkable contributions to applied mathematics, differential equations, stability and control theory. He holds MSc, B.Ed, MPhil and PhD, and his research excellence is reflected in his extensive scholarly work. Today, he has authored and published 79 research articles in national and international peer-reviewed SCI and Scopus indexed journals. Dr. P. Muthukumar sir's commitment to academic excellence extends to research supervision, having successfully guided 10 PhD scholars with several more currently under his mentorship. His research endeavors have been supported by two major funded projects totaling 58.23 lakhs and 13.82 lakhs, highlighting his significant contributions to the academic community. So beyond research, Dr. P. Muthukumar sir has taken on key administrative responsibilities, serving as the Public Information Officer, Assistant Nodal Officer for CUET, that is Central University Entrance Test, and the member of IQAC Working Committee at GRI. His academic pursuits have also taken him beyond national borders, including a visit to Deakin University, Australia, for academic collaboration. Sir, it is indeed a privilege to have you with us today. Your presence and insights will undoubtedly inspire and enrich our academic discussions. So once again, I invite all of you for this IWMMDE 2025. With great respect and anticipation, now I invite Dr. P. Muthukumar sir to address the gathering. Thank you. Thank you.
Long introduction about me. Whenever I visit this Gobi Arts and Science, I imagine as a student only. So not much academic background I am getting. Anyway, so it's a great opportunity. I thank everyone of the Department of Mathematics for actually inviting me to meet you all. So this is a great opportunity. We feel that it is a great opportunity for everyone to know something about beyond our syllabus. We are everybody familiar. Every semester we had our courses, we have our teaching classes, everything is fine. So beyond that, what we are going to learn is important. Why? Because for our next step, for our next career, or our next higher studies, we have to know something new beyond that, what is going in this field of mathematics. So that is why this kind of workshop is important. Everybody know there are several words are using seminar, conference, workshop, symposia. So there are several words are using to conduct this kind of program. Particularly, what do you mean by workshop? Workshop means you have to take a specific theme or topic. You can have knowledge about this. That means one day workshop is not enough, as from my point of view. So we have to at least a week-long workshop is a good idea to enrich our knowledge. So for that, you have to select some of other grants. You people are know about this MTTS program. Everybody students have attended MTTS program. Minimum a week or 10 days programs. There are much MTTS. Fine. So you know the experience of MTTS. How the regular teaching classes differ from MTTS classes. We have a rigorous inputs. Basic fundamentals now.
பட் இருந்தாலும் பார்த்தீங்கன்னா நமக்கு அந்த டீப் நாலேஜ் பார்த்தீங்கன்னா அப்படிங்கிறது பார்த்தீங்கன்னா அந்த ஃபோன் பாயிண்ட் அவுட் பண்ணிட்டு அது ஒரு அந்த நினைக்கிறேன் அந்த சேர்மேன் பார்த்தீங்கன்னா ஒரு ஐடி பர்சன் இஸ் அ தமிழ் பர்சன் கேசவன். So it is a good initiative by that forum. It is organized by the some alumni of this something like MTTS holders. What is that purpose of MTTS means you have to enrich your fundamentals of mathematics. So likewise here this kind of workshop is going to input some specific theme on in-depth knowledge in Padma. So in that way I have prepared a application for mathematical modeling or you can say application of differential equations in two way of stability analysis and control design. Everybody know from UG students or PG students, everybody know what you mean by differential equation, why we have to study differential equation. Differential equations and from the school onwards we are studying it. Application of differential equation is a school subject. What are the importance? Here we have to specifically differential equation. In addition to that, application of differential equation in real life. So that field of differential equation is more applicable or connecting with the real life problems. For example, engineering colleges. So before engineering colleges, only physics, chemistry, maths, basic science. After Second World War, the engineering developed. So we have to separately study engineering, mechanical engineering, electrical engineering, electronics engineering, something like that. Several branches of every year developed in the field of engineering. So for basic science, fundamentals, basic fundamentals, start applications engineering field, medical field, so definitely our mathematics field everywhere behind that mathematics. So the best examples are Gandhigram University is the best example. The Gandhigram University PhD scholars and mostly they are going to abroad. Abroad every they are going to get a postdoc fellowship. So the postdoc fellowship select departments of electrical engineering department, control engineering department. So not pure mathematics. So you applied mathematics then you have an opportunity. One of the students Deakin University of Institute. So that's why postdoc fellow Deakin fellow, Oxford Deakin fellow. Our monthly salary is 7.75 lakhs per month. So just imagine. So the importance. So BSc Maths, MSc Maths, PhD Maths. When you are going to working with the electrical engineering department as a postdoc fellow, they are considering our knowledge. Mathematical knowledge we are paid much on the fellowship because on the amount of fellowship we are going to enjoy. So now this is a sample example. But students they are get well placed. Another own student, another student placed. So however, biological modeling, population dynamics, great data models. So on the field very simple. Or mosquitoes, dengue create mosquitoes reproductive natural modeling under what kind of situation of field of research separate department biological biology. So if other type of development so engineering field biological field or any kind of situation recent as well AI, something like data science. There are many fields they are behind on mathematics. Another thing recent quantum computing. So quantum dynamics, quantum dynamical system, quantum control. So new field emerging. So future world quantum computing. That means if you have a normal system create password ATM password whatever net banking all passwords within a second break quantum computing. we have to create a more stronger secure system by using quantum computing. Other than system. So how we have to develop quantum dynamics, quantum computing. So when we can speak a lot of application of mathematics, particularly on the differential equations applications in the basic curriculum. Here I am going to point it out for the dynamical system indicator, how we have to analyze the stability and control of the curriculum. Till the end of the basic research work, you can put it for your project or something, your higher studies will be you can use it or you can enjoy the further studies in this field. Okay. So outline now, you can enjoy it. So first thing, what is the meaning of dynamical system? Differential equations, what do you mean by differential equation? Anybody? Simple differential equation என்ன சொல்றீங்க? Algebraic equation தெரியும்ல? Algebraic equation அப்படிங்கிறது just வந்து பார்த்தா நமக்கு combination of நமக்கு எப்படி இருக்கு? Variables and coefficients, then arithmetic operators, then you can form an equation. That is called algebraic equation அப்படின்னு சொல்றோம். So likewise if an equation which involves derivatives அப்படினாலும் you can simply call it as differential equation. அப்போ என்ன derivative இருக்கு? What will be derivative? Derivatives now, there is a function y is equal to f of x. You can able to differentiate y with respect to x. Here x is called independent variable, y is dependent variable. So, okay, so இது எப்படி சார் நம்ம வந்து பார்த்தீங்கன்னா மாடலிங்ல or application வந்து பார்த்தீங்கன்னா ரிலேட் பண்ணுறோம் அப்படின்னா we have to point out that two meanings of a derivative. ஒன்று வந்து பார்த்தீங்கன்னா geometrical meaning, another one is called physical meaning அப்படின்னு சொல்லலாம். What do you mean by physical meaning? Everybody know. Physical meaning of a derivative simply called as rate of change of time. Okay, right? Physics நம்ம அதை எப்படி ரைட் பண்ணுவோம்? Rate of change of displacement. Rate of change of displacement வந்து என்னன்னு சொல்லுவீங்க? Call it as velocity. Clear? So physical meaning of a derivative is simply call it as velocity is the first derivative. Second derivative அப்படினா acceleration is going by. அப்போ you can easily connect a mechanical system. ஏன்னா velocity, acceleration எல்லாமே யாருக்கு வர போகுது? ஒரு moving object வரும். இல்லையா? So that we call it as mechanical system அப்படின்னு சொல்லி. அப்போ once you have a mechanical system அப்படினா you can able to identify that position, displacement equation சொல்லுவோம். Then you have to write the rate of change of displacement. You can find the velocity அப்படிங்கிறது. எல்லாருக்குமே தெரியும். நம்ம டூ வீலர் ஓட்டுறோம் அப்படின்னு பார்த்தா we have a speedometer. என்ன ஸ்பீட்ல போயிட்டு இருக்கீங்க? 80 km ஸ்பீட், 60 km ஸ்பீட் அப்படின்னு சொல்லிட்டு அது தாண்டும். ஸ்பீட் வெலாசிட்டிக்கு என்ன டிஃபரெண்ட்? ஸ்பீட் இஸ் ஸ்கேலார். இல்லையா? வெலாசிட்டிங்கிறது வெக்டார் குவாண்டிட்டி. வெக்டார் மீன்ஸ் both magnitude and direction. நம்ம வந்து டூ வீலர்ல ஸ்பீடோமீட்டர் வந்து பார்த்தீங்கன்னா நீங்க எந்த ஸ்பீட்ல போறேன்னு காட்டும். பட் நீங்க எங்க போறேன்னு எனக்கு தெரியாது. அப்படிதான் நீங்க பைக் எடுத்து வேகமா போறீங்க, பைக் எடுத்து வேகமா போறானே எங்க போறான்னு தெரியலையே சொல்லுவோம். இல்லையா? பட் அதே வந்து பார்த்தீங்கன்னா ராக்கெட் லான்ச் பண்றப்ப வந்து பார்த்தீங்கன்னா என்ன சொல்றாங்க? சேட்டலைட் லான்ச் பண்றப்போ they have to mention that velocity of the launch vehicle. சரி, அந்த ராக்கெட் velocity என்ன அப்படின்னு சொல்லுவாங்க. என்ன they can able to predict both the magnitude of that means speed and direction. சரியா? என்ன ஸ்பீட்ல போகுது, என்ன டைரக்ஷன்ல போகுது, whether it is the right direction or wrong direction போகுது they can decide. Once it is goes wrong அப்படின்னா பார்த்தா they have right to control. The right direction பண்ணுவாங்க. Otherwise they will destroy in the space itself. So as well as the success of the various mission on தெரிஞ்சிருக்கு. சந்திராயன். இல்லையா? So அந்த மாதிரி எல்லாம் so I think this is clear for you. Yeah. So how we have to physically model a differential equation அப்படிங்கிறது. So இதோட applications வந்து பார்த்தீங்கன்னா இந்த மாதிரி நீங்க mechanical system we have to identify that. So okay, so come to the dynamical system. So dynamical system is a general modeling of system that is called a differential equation. Or general things are what is that meaning? A system is defined as a collection of set or arrangements of objects. Another thing, a system is called a dynamical system if it is varies with respect to time. So it's a kind of similar differential equation, but it will evolve with respect to time. You can also generally you have to model it as f of t comma x, f of t comma x of t. So this x dot of t, this x dot of t. So X is a dependent variable, T is an independent variable. This X dot of T is a time derivative of any mechanical system that will evolve with respect to time. So that will be matched with the nonlinear function f. So this f of t comma x of t is a nonlinear function, purely nonlinear function. So this general representation called it as dynamical system. Particularly, this is a nonlinear differential equation, or you can say it is called the initial value problem. Why we have to call it as initial value problem? So this initial condition represents the starting position of the object or something particle, moving particle. That is, at time t is equal to t naught, your position is x naught. So this x is a state variable or state vector. The state vector belongs to r power n, or you can represent this f is a function from r plus r cross r power n to r, so which is called the general dynamical system, which is described from the initial condition at time t is equal to t naught. Right. So simple example of a dynamical system is something mass spring system is called a simple harmonic motion effect on this mass spring system. You know that Hooke's law. Anybody know this Hooke's law? The force generating. If you are going to stretch the mass certain distance, it is attached with the spring. You can able to stretch. Then it is oscillating. Simple harmonic motion generates. This generating force F is directly proportional to the displacement. How much the displacement? That is directly proportional with the force generated by the spring or something like. So this K coefficient K is called the stiffness of the spring. So based on this, we can able to write the differential equation of motion. It's the best law, you know, that Newton's law. Here we have to apply Newton's second law of motion. So Newton's second law of motion, what is that? F is equal to ma, mass into acceleration. So simply it is a second order differential equation. Once you know the acceleration means is the rate of change of velocity. That means it is the double derivative of the, what is that? Displacement, right? Equation. Displacement equation, double derivative, we have to find the acceleration, right? So F is equal to ma. So based on this, you can rewrite the velocity equation. Velocity equation, first derivative. Okay, so first derivative equation is by using the Hooke's law, you can write it as the, what is that? Acceleration, right? So minus k by m into x. Velocity equation. So acceleration or something like equal to minus k by m into x. Another thing is called the rate of change of displacement equation. So this is acceleration equation, this is the velocity equation. So by using this, you can write the system of equation. So system of equation, there are two variables x and v. Both are interrelated by means of x dot is equal to v, as well as v dot is equal to index of x. That is called the coupled equation. Sometimes here it is a linear, sometimes it becomes a non-linear. Then you can have a generalized equation of non-linear first order differential equation. So basically, we have to start from Newton's second law, which is the second order differential equation. That second order differential equation can be represented as system of first order equation by using this kind of substitution. Then you can have the dynamical system. Y dot is equal to ay. Generally, it is called a matrix differential equation. This is a matrix. This is a homogeneous first order linear differential equation. So you know this meaning of y dot is equal to ay. Fine. So here this state vector is two variable x and v, and the coefficient matrix is a constant. So this is a general representation of a mass spring in terms of a dynamical system, particularly linear case. Simple one. Then second thing is we are going to discuss analyze control system. Very simple. Why we have to use the control variable in a differential equation? So I think here MSc mathematics students are going to study control variable, right? So it is very simple logic. We have to fix a target. So that means I need to reach my home at this particular time. So at 1 o'clock, I need to be there in that particular place. So you have to fix a target. You have to fix the time. So you have to reach within the specified or prescribed time. You have to reach the target. Then you need a appropriate control. So for example, if I'm using a two-wheeler to reach the particular spot in a specific time. So I need to control or make an adjustment with my accelerator of my two-wheeler. So here the accelerator is a control variable. So what kind of speed is enough to reach the destination in the prescribed time. So that is called control equation, control system or control differential equation. So there is an additional variable you have to represent the dynamical system. So here there is a control variable. Let's generally call it as control system. There are many applications, temperature, voltage, something like we have to controlling that velocity, we have to controlling that acceleration, something like it. There are many variables that can be represented as a control variable, and the corresponding system is known as control system. Right. So next we have a classification of control system. One is called the open loop control system. Another one is closed loop system. There are some advantages and disadvantages both the case. There are simple thing is called the open loop control system. For example, a traffic light control without sensor. Without sensor means you cannot adjust the signal time. If you face the signal, the signal time is 30 seconds or 60 seconds. By default, if the vehicle is there or not, we have to wait for 60 seconds to allow opposite direction. So it is an open loop control system. That is why without any sensor, there is a traffic signal that is called open loop control system. So here generally we can call it as input, controller, actuating signal, plant. Plant means simply our dynamical system. Then we have an output. This is a forward direction of system. We can have a control system. We can have open loop control system. Second thing is closed loop system. So this closed loop system is very simple. The output will be redirected to the input according to our desired nature. So our desired output, till we have to reach the desired output, we need to send back to the obtained. So what is that? First received output will be feedback elements. We have to connect with the feedback elements. So some testing is going there. Then we have to improve or something like correct the errors. So to enrich the signal output. So that we have to achieve the desired output. So final output will be there is one. So the final output will be compared with the receiving inputs. So this receiving output will be connected with the feedback elements. Then feedback elements will improve or something like reduce the errors. That is called a closed loop system. So closed loop system again, where the example, the traffic light signal example, which have a sensor. Which have a sensor means, so what do you mean by error here? Here error is suppose there is no vehicle on one side. So there is no need to put a waiting time. So there no need to put a waiting time. So that you have to correct the thing. So we have to reduce the timings. Suppose if we default by fixing 60 seconds, there is no vehicle or less number of vehicles. So we need to we have to change into 30 seconds. So ultimately we have to correct the waiting time of the signal time according to the nature of the number of vehicles in the particular road or something like direction. That is called the feedback method. So feedback method you can able to adjust the desired goal. So what are the differences? There are some list of differences. You can read it. You understand that what is mean by open loop control system, what do you mean by closed loop system. Some advantages, some disadvantages are there. Right. So further, you have to read the feedback control system. Feedback plays an important role in order to improve the performance of the control system. There are several things: linear feedback control system, control loop, including sensors, control algorithms, actuators. There are several things in practical applications is going to regulate the state variable, set the desired output. The second thing is example of a closed loop control system is best example is called the human brain. So why you have to consider a human brain is a system, that means dynamical system, because we are receiving the signals by various sensors. Various sensor means we have to see the object, we have to hear the noise or sound, we have to smell the thing by nose. So there are several aspects, or we have to touch by our fingers. There are several sensors, we can call it as an input signals. all the input signals are going into process with our brain. Our brains are going to calculate it, what exactly we are going to do. For example, if you are going to pick an object or whatever you want to do in an exercise, then there is some process is going there. Then again we have to analyze the signals. Then we have to decide the output. Output will be from the analysis of what is that our brains sensors, brain's calculations by using that different sensors receiving by the our eyes and nose, everything. Okay. So this is the best example for a feedback system. Another thing is we have to model as a state space model. Why we have to come to this kind of models is that we are going to consider a feedback model. So in our study of analysis of stability and control design, so we have to analyze a separate output equation. One is the normal input equation, x dot is equal to ax plus bu. So this, you just remove this term. What is this? X dot is equal to ax. This is a simple linear homogeneous first order matrix differential equation. It is not enough to analyze our target desired output, so that I need to add a new term that is called, what is that? V into u. U is control variable, that is an input case. External input. V is a coefficient matrix. Whatever you want, you have to work out on this. Whether we have to increase or decrease according to, you have to decide the coefficient matrix, whether it is plus or minus something like. So based on this, you have a output. So this output is also another equation, simply an algebraic equation which depends on both variables. One is a state variable, second one is a control variable with some coefficient parameters. So this is a generalized form, so you don't bother about that. Simply the state equation is depends on x and u. The output equation is depends on also x and u. Here it is a differential model. This is simply a function. So linear function or something like non-linear function depends on your mathematical model. So you have to write that state space model for any kind of mechanical system. You have to analyze for control design as well as stability analysis. So here I have to mention that all the notations will variables. You can see and verify that. So second thing is again I have to come for feedback control system. Simple open loop control system. Basically our control data is subject to what we mean by controllability. So here it is linear equation x dot is equal to a into x plus b into u. So previously we have to see this coefficient matrix are constant is. It is a simplest one, linear time invariant model. Here it is a linear time varying. Time varying means your coefficient is also depends not only the numbers, simply numbers, it is also depends on time. So it's kind of time varying system or time invariant system based on the coefficient. X is always a function of time, so there is no change in this x. But if you design that model equation with based on the coefficient, you can classify that it is linear, non-linear, homogeneous, non-homogeneous, time variant, time invariant. There are several cases you can classify that. Here it is an open loop system. How we have to identify the control design. Control design by using that Kalman conditions. We have a controllability Gramian matrix. Based on the controllability Gramian, you can design control to reach the target. So already I discussed with you what do you mean by controllable. So we have a desired target. We have a desired desired target during the prescribed time. So your starting time is 0, your final time is final capital T. Some is 0 seconds, some is 50 seconds or 60 seconds. You have to start from the position x naught. What is your aim? You are going to reach x1. For example, if you are considering a satellite launching, so there is a orbit position. They have already scientists are fixed the particular position of the orbit in the Earth orbit, something like moon's path. So we have to place the satellite in the particular position. So that target is defined as x. Also, the scientists are fixed the time. How many number of hours or seconds we have to reach from the launching position to that satellite placing position. So we have to decide that particular trajectory also. That kind of here there is no prescribed trajectory, only starting position and final position. There is another research called as trajectory controllable. You can see the literature. There is another research called as trajectory controllable. That means you have to also decide the path. For example, if you are going from here to your home, there are several ways. There are multiple ways you are having to reach your home. What you are going to decide. So you have to select the particular path or route to reach your home by the way of shortest time or whatever it may be. Whether suppose you want to see some places or bakery or something like that, you have to select another whatever it may be. So there is a prescribed trajectory also. Some cases we are also going to fix the trajectory. So for that case, there is a called as prescribed trajectory. That kind of controllability is known as trajectory controllability. So this is the simplest one. Only we have to fix the starting position and final position and prescribed time. During that prescribed time, you should design the control U such that you can reach from this position to that position giving the time 0 to capital T. So simple harmonic oscillator problem of second order differential equation. You are familiar with converting the second order into system of first order by the way of substituting. What is that? X is equal to x1, x dot is equal to x is equal to x1, x dot is equal to x2. Then you can find what is x1 dot and x2 dot. Then you can write the system of equation by using this. Okay, I think your MSc students are studying this number. Fine. So here initial value problem. So I have an initial condition. Also there is a final target position x1 of capital T is equal to x2 of simply 1 by 2. Fine. So how we have to decide? So there is a simple method, call it as Gramian matrix. There is a steering function. There is a Gramian matrix. You can identify Gramian matrix is capital X. So this is known inputs. B star is transpose. M is given. So with this X is unknown. What is X here? Anybody? What is this X? It is called as fundamental matrix. Okay, so fundamental matrix of my control system, but I'm going to consider only this homogeneous part. For finding fundamental matrix, we have to consider only this homogeneous part. Then you have to easily find. There are several methods for finding fundamental matrix. The definition of fundamental matrix? It is a what about the columns of the fundamental matrix are linearly independent also. So linearly independent only linearly independent is enough. So satisfies. Is a solution of your homogeneous part. I have pointed out that homogeneous part. You have a solution of homogeneous part and also linearly independent. That means linearly independent solution. For example, 2 cross 2 matrix of A, you have 2 linearly independent solutions. One is cos t minus t and minus sin t minus t, one solution. Because the solution is x belongs to R2, 2 cross 2 matrix system. And that this is a x1, x2 solution. So x1 is cos t minus t, x2 is minus sin t minus t. Another solution is sin t minus t and cos t minus t. So this is linearly independent solution. So how we have to identify that 2 cross 2 system will have a 2 independent solutions. There is an interesting theorem. If we have an n-dimensional system, state space vector, R of n-dimensional vector system, you have a n linearly independent system. That is why there is a system, there is a theorem states that we have a you have to find the control. You have to find the inverse of the matrix. You have to find the control U. So based on this U, you can able to reach the solution. You can able to find the solution for the non-homogeneous. This is a non-homogeneous first order linear equation. So how you have to write the solution? Anybody? For the homogeneous, you are ready with the fundamental matrix solution. For the non-homogeneous, how to write the solution of the first order differential equation? For non-homogeneous case, there is a method called it as how to write the solution. Constant variation of constant formula. Can you clear that? The MSc students know the variation of constant formula. Okay. So for the non-homogeneous case. Anyway, so by using that solution, you can apply this U. You can write the solution. Then you have to apply the initial time 0, 0 and also capital T that will produce 1 by 2, 1 by 2. Okay, so this is target. So it's a simple open loop system. Basically, Kalman's rank condition, you have to identify that whether the system is controllable or not. Also, you can able to identify exact control. What do you mean by exact control function? By using the Gramian matrix function. Right. So second thing is stability. So I'm going to point out that what do you mean by stability? So this is a basic theoretical way of saying stability of the particular nonlinear. So this is a first order nonlinear initial value problem. If the dynamical system, you can consider the first order dynamical system. When the initial condition is x of t naught is equal to x naught. So here x is an R power n generalized case. F is as usual we have an R plus cross R power n to R power n vector. Okay. So t is a continuous time variable. Now you have to select the point xe. So this xe is called equilibrium point. So this is an important thing. Every stability of dynamical system based on that equilibrium point, or you can say sometimes it is a critical point, or you can say sometimes it is a maybe fixed point. So there are several meaning of different locations. So if you are going to biological systems, they have to select the fixed point as an equilibrium point. Sometimes we have to engineering people are using that critical point or something like it. So there are several meanings of this xe. Here we have to mathematically we have to find out the equilibrium point. Very simple. There is a right hand side nonlinear function. You have to find a value of xe such that what is right hand side? So this right hand side is an R power n. So that means this is an n cross 1 matrix valued function. N cross 1. So that means n number of algebraic equations. You have to write the n number of algebraic equations which is equal to 0. Equal to 0 is very simple. Equal to 0 means this x dot is equal to 0. What is derivative is equal to 0? Then the function is constant. That means I have to basically pointed out that one is a definition of physical meaning of derivative. Another one is there is another one derivative meaning of a derivative. It's called what is that? Geometrical meaning. What is the geometrical meaning of derivative? Tell me. What is the geometrical meaning of a derivative? Call it as simple first order derivative of a variable. Call it as slope. Anybody know the slope of the straight line y is equal to mx plus c? What is the equation of the form? Slope and y is equal to mx plus c is the equation of the straight line. Call it as slope and what is c? What is m? M is slope. So if you are going to y is equal to f of x, that is f of x is mx plus c, then you can find the derivative. Dy by dx is simply what you get for that equation y is equal to mx plus c. What is dy by dx? Yeah, that is called a slope. That is why I am saying that geometrical meaning of the derivative is simply slope. But see here, only concept there. Another any other meaning. So, what is how to measure c in that equation? If you sketch the xy plane, y is equal to mx plus c. how to mark M? M is equal to again M is the tan theta. Okay, what is theta? Angle made by the straight line with what? Huh? Okay, school level going to put 10th, 9th, 8th, right? Anyway, so theta is the angle made by the straight line. So your straight line y is equal to mx plus c with the positive direction of x-axis. Definitely, your straight line must cut the axis. Yeah. So because axis is also going, your straight line is also going. At only point of time, your straight line must cut the axis of x-axis. So you can able to measure that angle made by the straight line positive direction of x-axis. That is called theta. That tangent value is called slope. How we have to match with the slope is dy by dx. Okay, so differentiate one now. We will get a fine. What is tan theta? Tan theta, by the definition of tan theta, is simply opposite side by adjacent side. Okay, fine. Opposite side by adjacent side. Okay, so opposite side is change in y, vertical axis. Adjacent side is change in x. Change in y is measured by dy. Change in x is defined by dx. So that I have to write dy by dx. You can mark it. Okay. That is the part of straight line is okay, sir. But how we have to apply y is equal to f of x or x star is equal to f of x. So f of x is a function, any curve. Function means any curve. Not necessarily it is a linear, not necessarily it is a straight line. So it is an any curve, non-linear structure. So how we have to again the derivative at a point of the function? It is the tangent. That straight line is simply the tangent at the particular point. Then you have to find the derivative at the same point. So you have to find the derivative at a point is simply you have to draw the tangent. That tangent obeys the same rule. That means what is tan theta, what is dy by dx, what is the rate of that is opposite side, adjacent side. You can form the right hand. So all those things are simply called as geometrical interpretation of a geometrical representation of a derivative. Okay, so you don't forget. This is a basic fundamental question. I can give an example. First interview of my after MSc. I don't know. So you know, solid matriculation students are doing. So that is my first interview. If I ever asked this kind of questions. First interview I never forget. Okay. So fine. Anyway, so these are all some basics behind this. Here, what is I pointed out here? F of txt is equal to 0. That means derivative is equal to 0. Where the derivative is equal to 0? That is my question. From the geometrical interpretation, dy by dx is simply m is equal to 0. Right? The derivative is equal to 0 means m is equal to 0. Where the slope is equal to 0. What will be slope? Where the slope is equal to 0. How the tangent becomes? Suppose that tan theta is equal to 0 means theta is equal to what is theta? Tan theta is equal to 0 means where and tan theta going to 0. 0. Simple. So angle is 0 means what about the straight line? What is the theta means angle made by the straight line with the positive direction of x-axis. So theta is 0 means what about the straight line? What about the x-axis? Both are same. Simply it is a horizontal line. So the slope is horizontal. Slope is horizontal means there is no slope. Suppose if you are seeing this floor, can you say this is a slopey surface? No, it is a horizontal surface. If you are going to sliding a what about that hill or something like that, you can see the deep snow, so you cannot climb it. Something like we are going to say, so that we have to identify that the angle, so 30 degree, 40 degree, 50 degree, 60 degree. So that kind of slope is there. So that you have to identify that this position is either the curve is in a maximum value or the curve is in the minimum position, maximum or minimum. That position you can identify that xt. What is that xt? That xt becomes, that is the position of the function. That xt becomes the corresponding tangent at xt. Corresponding tangent line at xt of this function f of dx is horizontal. Once it is a horizontal becomes, there is no slope, there is no theta is equal to 0, then ultimately derivative is 0. That position is called equilibrium point. Simply you have to understand that equilibrium point is the either maxima or minima location of your nonlinear function. Your nonlinear function here. I think this is clear. So geometrically, if you are enjoying this, then you can easily understand it. So I don't want to waste the time further. So on this in-depth analysis of equilibrium point, anyway, you have to identify that equilibrium point by using this equation is equal, by solving this equation is equal to 0. So from this equilibrium point, how I can say that the system is stable one? By the mathematical definition, as like our continuous function, differentiable function, you have to write this non-definition, you have to write this equation, let's say is the corresponding statement. So how you have to geometrically view this? There is an epsilon neighborhood, there is a delta neighborhood. You are going to start from epsilon delta neighborhood. Whenever this your starting position is delta neighborhood, you have to move around over the time period. For example, t not equal to tends to infinity, some point of neighborhood point. You have to come close with some epsilon neighborhood, then you can say that this is stable. Asymptotically stable means you have to converge to the origin. Okay, so that origin means here xt. So you have to start from this x naught, you have to go around that epsilon neighborhood. Then again, at point as t goes to infinity, you have to reach equilibrium point xt. Then it is called asymptotically stable, exponentially stable in terms of this exponential function. You can say it is also going to 0 as t goes to infinity. Because this e to the power is minus is greater than possibly. Right. So this is an exponentially stable. So these are all some basic mathematical definitions of stability. Okay. So now we are going to analyze for the practical point of view, for the mathematical modeling point of view. This kind of exact solution is many times it is not possible, because this you know that we have a common formula for solving quadratic equation, but we don't have a common formula for solving any first order differential equation or any second order differential equation. Is there any common formula? No. For every case, we have to apply a new technique or new formula, then we have to find the solution. So this is something difficult for finding exact solution or actual analytical solution of a nonlinear differential equation. Linear equation is something difficult, but still nonlinear equation is also very, very difficult. That is why we are going to study many numerical methods. Anyone pointed out that for solving differential equation, any numerical method? Anyone have numerical methods for solving a differential equation? Euler method, Navier method, you know that, yeah. So there are several methods there. Why? Because there is no exact formula, there is no analytical solution for the differential equation, particularly linear, non-linear case. So then we have to go for a numerical case. Fine. So based on that, we have to develop. We need to identify a suitable stability method to analyze the solution or something. Without finding the solution, we have to find the what is that? Stability of the system. Instead of identifying the x of t, that is exact analytical solution. What is here? So Lego is very old thing. So it is developed there kinds of methods. First one is indirect method. So indirect method is again you have to go for linearizing the nonlinear model. Then you have to analyze the stability. Then it is very difficult. Okay, so some situation, for example, you need an eigenvalues. So in this case, you have to identify the eigenvalues. So this eigenvalues identification for 2 cross 2 matrix is easy. 3 cross 3 matrix is finding an eigenvalues is easy. But if you have a 10 cross 10 matrix, how you have to find the eigenvalues, eigenvectors? That is difficult. So that is why. So this is something cost-effective method. You have to go for another method. Which I have to say it is a direct method. So this method is more powerful in the solution of differential equation, particularly computational cases. Particularly, we have a MATLAB, there is a linear matrix inequality techniques. So we have a solution like energy. So any mathematical model of a physical system, if you able to do the kinetic and potential energy, immediately you can able to define the Lagrange. So from the Lagrange function, you can able to model the movement of them. That means evaluation of a system in terms of Euler-Lagrange equation or Lagrange's equation of motion, Hamilton's equation of motion. There are several things will be behind the classical dynamics theory. So from the energy concept of energy, we have to find the total energy of the system is dissipated, so that it is constant or something like a conservative nature. Then the system is always stable one. Now the concept of energy, which is much will be used in engineering practice, not our mathematical point of view. For the application point of view, this kind of energy equation is always applicable in the modeling of a system, maybe any electrical engineering problem or mechanical engineering problem. So engineering people are likes to find the concept of energy. You can able to represent the system. So this function you can use the potential energy for conservative mechanical system. You know that conservative nature, conservative mechanical system. Anybody? What do you mean by conservative system? Total energy is constant. So there is kinetic energy plus potential energy is called as total energy. So the total energy is constant means of the motion. You can say that system is called the conservative mechanical system, which is local minimum. That equilibrium state is stable. So local minimum. So how we have to identify that equilibrium point? Either it is a maximum or minimum. Then you have to find the local minimum of the energy function, which is stable equilibrium state. Okay. So this is a local maximum. If you have a local maximum, then the equilibrium state is unstable. This is simple logic here. How you have a local maximum is unstable, local minimum is. So if you have a bowl-shaped particle, suppose if you have a bowl, you are going to place a particle inside the bowl. You are going to shaking the bowl, then a particle is moving around. After a certain interval of time, then the particle is come to rest at the lowest point. That is called the local minimum. The lowest point is called the local minimum. The same thing, if you imagine that bowl is in upward direction, then you have to place the particle, some round shaped particle or spherical shaped particle on the top of the bowl, the inverted bowl. Then a small disturbance, what will happen? The bowl comes down. There is no chance to go back to the maximum position. So that is why you have to say local maximum is an unstable position. After a small disturbance of the particle will not come to the epsilon neighborhood. Okay, so if you have a disturbance means it is a delta neighborhood. Making a disturbance in the delta neighborhood, you cannot reach the position. That means epsilon neighborhood around the equilibrium point is called as unstable one. So yeah, okay. So if you are in that local minimum, then you will reach the stable nature. If you in the maximum position, that is vertical position, upward position, you cannot reach the equilibrium state. That is called the unstable nature. So this is an interesting feature by using this energy thing. You have to identify that Lagrange method in detail. Yeah. How we have to find this transpose that is symmetric nature. M is equal to M transpose. This M is a positive definite if the quadratic form, right? The X transpose Mx. So this is a general analysis behind the positive definiteness of matrices. Okay. So semi-definiteness is also equal to 0. There is a lemma. And say what do you mean by Lagrange function? Again, already I told that is a energy kind equation. That energy kind function will have the property of quadratic structure. P of 0 equal to 0. P of x is greater than 0. And for all x not equal to 0. It is a kind of bell-shaped nature, function nature. Lagrange function nature is a bell-shaped nature. So you are going to travel around the surface. That is called the background of the theory is called the convex optimization technique. So you have to reach the equilibrium point by using the convex optimization technique. You are going to travel along the surface of the bell-shaped curve. We can call it as Lagrange function. In detail, we have to see the definition of the Lagrange function. Is same thing. One is positive definite. And also, we have 0 equal to 0. And we have x is greater than 0. then V of x satisfies this condition, we can say it is a linear function. What are the advantages? You have to analyze the stability of the nonlinear system without explicitly solving the dynamical equation. So this is a great advantage for this method. Without solving the equation, we have to analyze whether the system is stable or not. Best example is if you consider this fan is rotating, it is a moving object. The moving object means it is not a translation movement, it is a rotational movement. How do you say that whether this fan is a stable system or unstable system? How do you feel? Whether it is stable or unstable? Stable with respect to that axis. Axis means the center point of the fan. So there is if you touch the fan, have to switch it off, you have to touch the fan, it is oscillating. You touch it, free oscillating. But during the rotation of the first speed, second speed, third speed, it never thinking about this axis because the design of the fan is the stable about the axis. Such a kind of behavior is we need to for every vehicles. If you are traveled by a car or if you travel by a two-wheeler, if you feel comfortably smoothness, you are enjoying the smoothness, that vehicle is a smooth or stable one. If you are traveling at 120 km speed in a car, there is no impact on it within the passenger. Okay, you are very comfortable within the car, even the car is moving with 120 km speed means that vehicle is a stable one. So that kind of application is essential to analyze every mechanical system, whether it is stable, in every moment, in every condition, in every disturbance, in every uncertain behavior, uncertain situations. So you have to analyze the stability of the thing is very, very essential. So that is why the people, particularly engineering people, are most enjoying this kind of analysis technique for their practical applications. So here some advantages are I have pointed out that one is without solving the explicitly you have to analyze this. Another thing is you have to determine asymptotic stability as well as normal plane stability. And also you have to determine the region of asymptotic stability where the system is stable. A single point is not enough. We have to identify some region. Around this region, your system is stable. Then it is enjoying a thing we have to. Practical application is not only a single point, its region is done in schema. So for in terms of Lyapunov function, there is a theorem called as Lyapunov stability theorem. How this positive definite function V will behave the corresponding system. System state is our x. X is our system state. Corresponding system is x dot is equal to f of x. For this you have a thing v dot v of x v dot. So this v dot is a time derivative. V is a function of x. How to find this time derivative of x variable? X is time dependent. How you have to find the time derivative? Chain rule or function of function. You can say it is a partial derivative. First you have to differentiate with respect to x, then x with respect to t. So that is v dot. V dot is a time derivative, but v is a function of x. We have to find this. You have to understand it. Partial derivative. For that we need a gradient of a function v. Fine. So we have to apply this thing for the Lyapunov stability of a linear system first. How we have to apply this kind of thing linear. So in controllability, there is a familiar concept called it as matrix Riccati differential equation. It's a kind of a Riccati type equation. It is a quadratic structure. You have to say this A transpose B plus B is equal to some minus Q, where this Q is what is that? Q is equal to Q transpose means it is a symmetric greater than 0 means it is a positive type. So this idea is applicable whenever we have used the Lyapunov theory, Lyapunov stability theory. So here this V of x is a construction of V of x is a big task. Here we have to identify the Lyapunov function in terms of an unknown function p, x transpose px. This p is satisfying this equation. So from this we can able to find a derivative which will satisfy all the definitions of all the conditions of what is the stability. V of 0 is 0, V of x is greater than 0, V dot is less than 0. So based on that I can understand that corresponding this V in the form of x transpose px for this linear homogeneous equation is stable one. Okay, so linear stable one. Asymptotic stability means from this P
then the Leibniz stability theorem implies that asymptotic stability. That means P is equal to P transpose. That is also P is also in a solution. We have a symmetric positive definite beats, not only symmetric but also positive definite beats. Corresponding stability theory you have to implies asymptotic stability. Hence, corresponding eigenvalues must be all the negative real part of the eigenvalues must be negatives. For every, suppose if we have an n-cross-n matrix, there are n number of eigenvalues. So that you have all the values are less than 0. Real part of eigenvalues are less than 0. Fine. So this is a general ideas behind the linear case. You have to apply this simple example of this equation. First thing you have to identify that eigenvalues. So all the eigenvalues have the negative real part. So that corresponding system is, what do you say, stable part. So same thing how we have to understand for the Leibniz theory. I have to put the condition Q is for simplest one. We have to select the identity matrix for this Q. Then you have to write the K transpose plus PA. This equation will generate a system of equation. By solving this matrix algebraic equation, you have to get the solution for each unknown variables of the corresponding P matrix, P11, P12, and P22. It is symmetric positive definite matrix. Ultimately, you can say that the corresponding system is stable. Here, understand that how the Leibniz theory applicable easily for the linear system. Okay, so linear system is fine. So very simple one. But in nature, in practical or in any application, so nonlinearity appears wherever we go. So without having a nonlinearity, we cannot have a good application. So it is interesting for applying the same theory for nonlinear case. So it is from the pendulum problem. I have to select the pendulum problem. Based on the Newton's second law, we can able to model it as a pendulum equation is theta double dot plus G by L sin theta is equal to 0. Again, by the substitution, you can able to write the system of first order equation. So this is our system. We are going to analyze the stability of this nonlinear system. How you have to say this equation number 14 is nonlinear? Anybody? Simple. Why? This is a nonlinear. Where the nonlinearity occurs? What is the nonlinear term here? What do you mean by first equation? X1 dot is equal to x2. Whether it is linear or nonlinear? What do you mean by nonlinearity? When we have to say the equation is linear, when we have to say the equation is nonlinear. Suppose I am going to write y is equal to mx plus c. What do you say? Whether it is linear or nonlinear? Why? Why you say it is linear equation? Tell me, just like this. Why it is linear? Y is equal to mx plus c. நான் ஸ்கெட்ச் பண்றேன் சார், அது வந்து ஸ்ட்ரைட் லைனா இருக்கறனால அது வந்து அப்படியே say correct or not. All the linear equations are graphically or geometrically straight line. Agree or not? Yes. Okay. So y is equal to mx plus c என்பது சரி. வேற ஏதாவது ஐடியா நீங்க நாட் சரி. சரி, ஒரு non-linear example சொல்லுங்க. Suppose can you say parabola or equation y squared is equal to 4ax. Whether it is linear or non-linear? Why? படம் வரைஞ்சோம்னா அது பேரபோலா சார், இப்படி வளைவா இருக்கிறதால வந்து இட் இஸ் நாட் a straight line. So that it is non-linear. Okay, geometrically நீங்க வந்து பாத்தீங்கன்னா அண்டர்ஸ்டாண்ட் பண்ணிட்டீங்க. Fine. So how you have to say y squared is equal to 4x is non-linear? Any other? அதுல இருக்கிற டேர்ம்ஸ் பாருங்க. y squared minus 4x equal to 0, something like that. இதுக்கு முன்னாடி சொன்ன ஈக்குவேஷன் பாருங்க, y equal to mx plus c. ஒவ்வொரு டேர்மையும் நீங்க பாருங்க, அதோட டிகிரி என்னவா இருக்கு? y டிகிரியோட வேல்யூ பாருங்க. mx டிகிரி, m கோஎஃபிஷியன்ட் கான்ஸ்டன்ட், x மட்டும் தான் வேரியபிள், அதோட டிகிரி 1, c கான்ஸ்டன்ட் வேரியபிள். சோ அப்ப எல்லாரோட டேர்ம்ஸோட டிகிரிஸ் எல்லாமே எப்படி இருக்கு? ஒண்ணா இருக்கு. இதே பேரபோலாவோட ஈக்குவேஷன் எடுத்துக்கிட்டா y square. அப்ப அல்டிமேட்டா நீங்க என்ன சொல்றீங்க? ஏதாவது ஒரு டேர்ம் பாருங்க, டிகிரி மோர் தென் 1 வரப்போ you can say it is a non-linear. So அதர் டெஸ்ட்ஸ் இருக்கு, you can just leave it. So you got to understand that sketch பண்ணா ஸ்ட்ரைட் லைனா வரக்கூடாதுங்கிறது ஒரு வே. டிகிரிஸ் பாக்குறீங்க மோர் தென் 1. சரி, இந்த கேஸ்ல ஃபர்ஸ்ட் ஈக்குவேஷன் லீனியரா நான்-லீனியரா? x1 dot x2 லீனியர். இந்த கேஸ்ல லீனியரா நான்-லீனியர்? நான்-லீனியர். எது நான்-லீனியரிட்டி? இப்போ டிகிரி எதுல g by l கான்ஸ்டன்ட்மா, x1 x2 தான் வேரியபிள், sin x1
How you have to say sin x வந்து பார்த்தீங்கன்னா linear or non-linear? ஏன் படம் வரைஞ்சு பார்க்குற சார் இப்படி எவ்வளோ போடுறாங்க ஸோ தட் இட்ஸ் non-linear. டிகிரி கேஸ் expand series expansion சொல்றாரு. What is series expansion of sin x? X minus x cube by 3 factorial x power 5. இப்போ எல்லாமே உங்களுக்கு என்ன வரும் டிகிரி? So infinite series would be approximation. Sin x இருக்குல்ல cos x also, tan x also, right? All are non-linear. Fine. So anyway, so it is a non-linear system. So how you have to find the Lyapunov function அப்படிங்கிற பாருங்க. Again energy க்கு வர total energy kinetic plus potential. So by using the law of something like this, law of you can able to identify what is the corresponding potential energy, kinetic energy of the pendulum case like this. Okay. So this is a mathematical model of a pendulum problem. Pendulum problem mathematical model you can able to derive this v of x, as well as v dot of x. V dot of x is equal to 0. You can say v is positive. So by using this equation, this is positive tape. What about that? Cos x na minus 1 v of x mgl or minus cos x1. So ultimately that value, the maximum value of the cos x is, what is maximum value of cos x? 1. அப்போ 1 minus something value maximum என்ன வரும் உங்களுக்கு? 1 minus of that value maximum என்ன வரும்? 0 தான். அப்போ உங்களுக்கு வந்துட்டு more than 1 வராது, so negativity வராது. Anyway நம்ம பார்த்தா this v is greater than 0, that is positive definite. So anyway, all the conditions of the electron candidate வந்து பார்த்தா satisfy பண்றதுனால you can say that it is the origin is the stable one, v of 0. 0 is the equilibrium point for this pendulum problem. Right, so this is one case. Suppose idile naam I have to identify that with friction. So some situation we have to consider friction situation. So this is physics and that case you have to write corresponding, what is that, system of equation, first order system of equation. So from this you have to write the Lyapunov function. Like I said, v dot is time derivative gradient into f. Like I said, dou v by something like x into x with respect to time. X dot x dot is f of x. Yeah, x dot is equal to f of x. So that I have to write this v dot. V dot is everything x2 square is positive, x square everything positive minus. So that v dot is less than 0. Therefore, it is 0 or y, so that it is negative. Semi-definite, not negative definite. So that the pendulum problem with the friction has stable based on this Lyapunov function, same Lyapunov function. You have to understand that this is a stable value. So without solving a differential equation, we can able to estimate or identify or classify that whether the system is stable or not. So this is another case, stabilization. Stabilization, if you go for a stability, you need not to input the control function, another external input. For the case of stabilization, we have a input variable that is Pu. For example, if you are considering a feed forward, feed back, then you have to write accordingly. This is corresponding homogeneous. How you have to say that the system is ultimately first the corresponding homogeneous system is an unstable one. After including this control variable, you have to make a stabilization so that the corresponding closed loop system, you have a closed loop system. That I will see that closed loop system is a corresponding matrix is a stable one, particularly asymptotically stable. Fine. So how you have to define this k based on the Kalman's condition? You have to design this k. How we have to find it? We have several methods behind this using into kx. So from this, I have to write the closed loop system. X dot is equal to bu. U is kx. So I have to write a plus bk. So this is basic MSc Maths compulsory requirement. You have this closed loop system. Okay. So what is this? Here we have a plus bk has only eigenvalues which have a negative real parts. Then you can say corresponding open loop system as well as closed loop system. What is that? It has a stable bar. Here 16 is an open loop system. 16 is an x dot ax plus bu. This u is equal to kx. U is a function of k into state variable. How you have to identify this k is a big task. So how we have to identify, there are several methods. One is Riccati equation. Then another one is our Lyapunov concept. So this is a closed loop feedback controller case. So for this kind of a nonlinear system, for example, this kind of nonlinear system, we have to identify stability of the system by using this linear matrix inequality. So simply I have to identify what do you mean by importance of linear matrix and inequality for the corresponding Lebno function is a stable one is. This is a nonlinear function. This is a small neighborhood around the equilibrium point. Here you have to consider if x0 is the equilibrium point. This is a small neighborhood of the equilibrium point. Around this equilibrium point, your nonlinear function is Lipschitz. So you know the Lipschitz condition from the existence uniqueness of the system. By using this Lipschitz condition and the linear matrix inequality and the linear matrix inequality in terms of your state variable. So this is a matrix equation which is less than 0. So this is a inequality. Less than 0 means it is an inequality, not equation. So this inequality will help us to say corresponding our system is what is that? X dot is equal to nonlinear equation. X dot is equal to f of x is a stable one. How we have to identify this? Look at that system. Look at the system. Linear case. We know that A transpose B plus VA is less than 0. So corresponding Lebno inequality that P satisfies this equation means corresponding equation is a stable one. So based on this case, how we have to ensure that asymptotically stable. So you need one thing is LMI, Lebno inequality is on P, and also you have to consider this step complement lemma. So step complement lemma is also from the linear matrix inequality F, that is F11, F12, F22 for the 2 cross 2 case. You have this function F11 of x is less than 0. This F22 minus this tail will be less than 0. Or you have this. So this is called it's a kind of special lemma which is from the matrix inequalities. So from this condition, you have to analyze that corresponding Lebno candidate is satisfies the stability of the given nonlinear system. So it is interesting for the higher order systems how the nonlinear differential equation is going to prove stability analysis and also control designs. Both the case you have to identify that. Simply I have to show this procedure. Here we have one more thing called it as just procedure lemma. This V0, V1 are two quadratic forms. You know that quadratic form is simply x transpose some positive definite matrix into x. So from this you have to identify that V0 is less than 0 and also satisfies another V1 with the inequality. V0 is less than epsilon times V1 in this domain for every x in R over x. Okay, so these are basic essentials for the nonlinear. Actually, this is a semi-linear form. If you are cutting or removing this case, you have a linear part. If you are including this, it is a semi-linear or non-linear term. Including this, it is called semi-linear or semi-linear form. Fine. For the Lipschitz, from the Lipschitz, you have to write this. Then already I show that you control input can be using this kind of thing. Then you can write the closed loop form for the semi-linear or non-linear case. And also the quadratic form of a Lebno function is like this x transpose P. This P is unknown. It is a symmetric positive definite matrix. And also the corresponding scalar function V is also positive nature. That is energy function for the linear case, similar to the linear case. So for defining here the Lebno function, we need a Hamiltonian. So again I have to taken from this classical dynamics theory. Hamiltonian procedure. So from this I can identify that V dot. This V dot is always satisfying this less than 0. Why? Because our H and another thing C is the constant function. Based on this nature, I have to identify that positive definite nature of C. We have a V dot is less than 0. So all those things are the conditions of the Lebno candidate. So that we have to understand that okay, this kind of Lebno function will ensure that corresponding system is stable one. So for this situation, we have to identify that LMI. So this linear matrix inequality is less than 0 and Q is greater than 0. This position is simply a matrix table. A transpose. So and also you have a K.
Already I told that we need U. Always we need U. Where U is Kx. So this kind of input is you have to make a non-linear system into unstable system into stable one. So for this we need this unknown K. From this we can also take the K from this equation expression. There is a MATLAB toolbox is available for computation purpose for solving this. There is a theorem. Now we have to verify all those things. It's interesting. We have to rewrite in the matrix form Z by Z. So Z is our variables like X here. This pi is also this. So from this pi, just I need to sufficient 37 is less than. It's interesting one. So from these are all some mathematical workout behind this linear matrix inequality goes to Lipno candidate makes stable one for the given system. It's interesting theory behind this. So you have to verify all those things, and finally you will achieve this equation is less than 0, Q greater than 0. Therefore, by the conditions of linear matrix inequality, by the statement of this theorem, and the corresponding system can be stabilized. It's interesting thing. This thing will be verified by using the numerical nonlinear problem. Very simple. There is a corresponding system can be written as a matrix equation. Then by using linear matrix inequality toolbox in the MATLAB software, one can easily identify that feasible solution for this LMA. Feasible solution means the corresponding matrix equation becomes less than 0. Nothing else you are going to analyze this. Actually, behind this theory is convex optimization. So once the convex optimization will satisfy it, and we will get a feasible solution for this LMI, then the corresponding Lagrange function will ensure the stable nature of the given system. So for this, I have to take an YU so that you can identify K. By substituting the K into the system, once you can solve this, you will get the stable solution. So there are some lot of computations behind this. You can enjoy if you are interested in this numerical computations. So another example also shown for you. If you are interested, you can take this example and analyze all those things. It's another example to know the stability of the system. So this is my conclusion. Basically, we have to take a linear model, non-linear model. Linear model is sometimes straightforward calculations. So we have a ready-made solutions, easily compute that solution. Then whether you can identify that whether that particular solution is stable or not. Same thing if you are going to apply the Lipno theory, that is also easy. So simple linear matrix equation going to solve to get the Lipno function. Then corresponding Lipno function will ensure that V dot should be less than 0 or less than or equal to 0. You can say that it is stable or asymptotic. So that is easy. Suppose if you are considering a non-linear model of a differential equation, you have to further depth analysis by using that linear matrix inequality theory, S procedure lemmas, complement lemma. There are some basic theories are going to apply to know the corresponding Lipno function should be less than 0. V dot should be less than 0. Some simple calculation and then. Okay, so based on this theory, you can apply many engineering. That is why I am saying that why my student getting a 4.7 lakhs per month is based on this theory. He is going to apply a control engineering problems or something is electrical circuit theory. How we have to apply it. So you know that recently electrical energy will not be come from a single source because power generation are multiple ways. One is windmills, solar. There are several in power generations are available. How we have to connect all those things, how we have to make an optimized utilization of a power distribution to the customers. So all those are interesting to make the wind farm is a stable model. Now recent days many electrical vehicles are coming. The customer is going to plug it in a particular position in a particular transformer. Suddenly the load will increase. That stability affected. So the system becomes unstable. So that you have to control the power load of the particular location, particular transformer. These are all some applications. We have to make a mathematical model. It should become either linear or non-linear. Accordingly, we have to analyze how much amount of the control we need to develop to apply the system makes the stable one. So these are all background applications of this mathematical theory.
So still, if you are interested, you can continue this as your MSc project or something like your higher studies. It is much interested on thing on many practical applications. That's all. So thank you for your attention. If you have any clarifications, we can discuss, or otherwise you can send a mail.
Yeah, I extend my heartfelt gratitude to our chief guest, Dr. Muthukumar sir, for giving or spending invaluable time with us. Thank you. And one thing I want to tell you that last week I have attended conferences at Bardiyar University and Periyar University, and all the talks depend on the mathematical modeling. So even though I know the definition of derivative, I couldn't understand why they have modeled using differential equations. So morning only I came to know this. I said something is, everything is depend on time will change. Everything is changed with respect to time. So that all the mathematical modeling comes under differential equations. So நீங்க ஏதோ பண்ணிட்டே இருக்காங்க ஒன்றும் புரியல அந்த மாதிரிலாம் எதுவும் திங்க் பண்ண வேண்டாம். ஏதோ ஒரு பாயிண்ட் ஆஃப் டைம்ல யூ வில் கெட் மோட்டிவேட்டட். ஸோ அதனால யூ திங்க் யூ லிசன் வாட் ஆர் தே ஆர் கமிங் டு சே. In any time you will get motivated. Right? Thank you.
break
Students are to present their shawl to the chief guest. I request head of the department to present momentum to our chief guest as a venture of engagement.
We would be honored to have Dr. P. Doraisamy sir to extend an invitation to the guests. We are confident that their presence would greatly enhance their contribution.
Good afternoon to all present here. I am happy to introduce our chief guest, Dr. P. Prakash, Assistant Professor, Amirda Viswanath University, Coimbatore. He completed BSc in Gobi Art and Science College from 2007 to 10 and MSc in PhD College of Art and Science College, Coimbatore, and MPhil and PhD in University of Madras, Chennai. He qualified CS Chairman, TNSET GATE exams in mathematical sciences. He has 9 years of teaching experience. He published more than 25 research articles in reputed science citation indexed journals. He has a visiting fellow position in IMS laboratory, University of Bordeaux, France for the year 2024 under International Mathematical Union, Germany and Siemens Research Foundation, USA. Recently, he received Young Scientist Award 2023 from the Academy of Sciences, Chennai. Also, for his single author contribution, he has received a A.M. Madhe Research Award 2020 from the Indian Mathematical Society, New Delhi. Additionally, he received Rs 21 lakh research fund for a PhD research scholarship for his PhD student under his guidance from the International Mathematical Union, Germany. His research interest is associated with developing analytical methods for scalar and systems of coupled nonlinear fractional differential equations that arise in physical models. More precisely, he has successfully developed the invariant subspace method to obtain the analytical solutions of the fractional order nonlinear PDEs. He was selected to present a poster and oral presentation on this relevant topic at 2 prestigious international mathematical events, namely the 5th Heidelberg Lawrence Forum 2017 and the International Congress of Mathematicians 2018, Brazil, under the funding of conference organizers and International Mathematical Union, Germany. I welcome Dr. Prakash to take over the session. Thank you all.
Sanjay.
Of the department and the organizing committee, completion and Kavita
that is for the content. And also other faculty members in the bodies for inviting me as a resource person in the international workshop on mathematical modeling in the situation. So here many students are undergraduate students. So here the main of this talk or presentation is existence and limits of initial value problem. Also, I will explain the linearly independent and dependent solutions of higher order linear homogeneous ODE. So, because you are many nearly 100 students are undergraduate students, right? So, maybe it's a very important whenever you are attending interview. So, if you are telling your specialization is ordinary differential equation or differential equation, mainly the questions will come in the area that is particularly existence and uniqueness. So also I will do some problem also, CSER related problem. I think it's a, because how to approach, how to solve, that is a very important. So it's a very easy, here I think you just all attended think about the CSER problems easily. Easily you can also. So now, okay. So now, first important topics in ordinary and partial differential equation. Because if you are attending any competitive exams like CSA or NET or GATE or SAT exam, the mostly the questions will come in this topic only. First, what are the topics that I will tell you in. Then, when we can say the given initial value problem has solution or no solution, currently any solution that I explain. Then Lansky and the linearly dependent. So now, if you are checking in GATE or NET or any competitive exams, these topics are important topics. So first, existence and uniqueness of solution of initial value problem first order ordinary differential equation. Then the singular solution of first order ODE, system of first order ODE, general of and non-homogeneous linear ODEs, variation parameter. Then boundary problem, Green's function. If you are checking the page, these topics are very important. Classification, Lagrange Chorbit's method, then this method of separation of Laplace wave equation, and the general solution of higher order PD. So these are important topics, particularly this existence and uniqueness. So here, that is we want to know clearly, right? So that are the exam point of view. Here, I am this slide very simple mathematics application. Why we want to study differential equation? We know a lot of application. That application related to linear or non-linear ODE or PDE. But we are actually very simple application than in terms of linear ODE. So you see here, the fundamental problem in biology is the variation of population, that is N of T, that is growth of any particular species such as bacteria or different. So this is a very simple application. This introduced by Thomas Malthus. This is called Malthus equation. So he published this model, the paper, an essay on the principle of population in 1798. So we stated the population models. You see, this is a very simple linear model. So this what is N represents? N represents the number of individuals at the time t. This K not be constant. N is the initial population. So this is a first basic model. So it's introduced in 1998, introduced by Malthus. It's not a mathematician, it's a economist. So it's not a mathematician. So whenever this K is greater than 0, then it represents linear growth load. Suppose you have population, maybe after 10 years, what is the population? This you can identify this is smaller. So your K is greater than 0, this is called the linear growth model. Whenever K is less than 0, the equation represents the linear decay model. So here the single value problem, it's initially solvable, right? It's a linear ODE. So initially we will get the solution also. The solution is here is given, that is n of p equal to n of t to exponential function that will involve scale. K is a growth constant. So now you see, whenever K represents 0, the population density grows with time. So whenever K greater than 0, that means whenever T approaches to infinity, n of T approaches to infinity. That means population will increase whenever K greater than 0. So if K is less than 0, the population density n of T decays with time. So that is whenever T approaches to infinity, n of T goes to 0. That means the population will decrease, right? So this depends on K is called growth constant. For example, very simple problem. So the number n of bacteria in a culture grow at a rate of n, the value of n was initially 100, increased to 332 in 1 minute. What is the value of n after 1.5 or 2? So this you want to calculate. It's easy to calculate. Not only this, even the population of begins and population of any galaxy developing from the growth model. So the value of bacteria, the culture, can be found in the Malthus equation. That is a first order linear value problem. But we have the initially at time t equals to what the number that is population is 100. That is the of 100. This K you want to identify because whenever K is greater than the bacteria will that means what we can say linear growth model, that means decay model. So now you see, this is a solution for the given initial value problem because it's solvable, right? So this is easily solvable. But at a time 1 hour, the population is 332, right? So 332. So now we have put in here. So t equal to 1 hour. The population is 332. So that means after into e power k into the time is 1. Right? If you are substituting, you will get e power k 3.32. So if you are taking logarithm on both sides, you will get k equal to 1.2. K equal to 1.2. This is a greater than 0. This means that bacteria population will increase. Right? So now you see, I want to calculate what is the population after 1.5 years? What is the population of bacteria after 2 months? That we want to calculate. So now NOT is exactly being calculated. That is 100. This 100 is a initial population. This 1.2 is a growth constant. That is positive. So therefore, this is a given model is a linear growth model. So now, if you are substituting right here 1.5 volts, you will get how much population of bacteria. That is easily calculated because instead of time, you are substituting 1.5 hours. So then 605. The population is increasing. Initial population is 1000. Now 605. So then after 2 hours, what is happening? So the value of the bacteria population after 2 hours is less than we are substituting here too. So we are getting 1102. So we can say any equation. Equation in a PD also, but the real world model need not be a linear model. So it's a non-linear. Whenever the non-linear is coming, the problem is easily we can't solve. So at least we want to talk about the solution is possible or not. That we want to know. And if solution exists, that is unique. So these two things are very important. So that that we want to discuss now, the existence and uniqueness. So the original problem in here, this is a simple linear problem, but the original real world problem linearity are not linear, that may be non-linear. Whenever non-linearity is coming, we got some already Marcel explained the stability analysis, right? Whenever the problem is not solvable, we can use the qualitative analysis to understand the behavior of the original system. So without solving, we can talk about the behavior of the original system using stability analysis. That is known as the previous part, right? So Marcel explained. So now I am coming to the existence and uniqueness. So now you see here, I am considering first order initial value problem. This f of x comma y need not be a linear one. It may be non-linear also. So initial condition. So therefore this is called a first order initial value problem. But if you have initial condition, solution is possible because the consistent you will get solution. So that may be you can find or you can't find. That is another problem. But if you whenever it's arguable, otherwise it's arguable. Okay, so whenever this initial condition is coming, we want to talk about the existence and uniqueness also, because this problem may not be solvable. Under what condition does the initial value problem have at least one solution? So at least one solution means that is existence. Existence means unique solution or more than one solution or infinite number of solutions or two solutions are possible. So what we want to know, the solution exists. Next, if solution exists, then that is unique or not. That is a second one important thing. Under what condition then the initial value problem have a unique solution. That is called a uniqueness problem. So that means we want to know, and the students you studied because we have the existence and the uniqueness, right? That is, we can apply any kind of problem or not. When because theorem is effective, then everything we want to. So now, whenever you are talking about the uniqueness, we want to talk about the Lipschitz condition. So Lipschitz condition means the right side function only, the left side is just linear, right? So this left side is just linear, right? Right side is, this is a non-linear. So this is f of x comma y is a non-linear, then the problem is not easy to solve. So therefore, now we want to talk about the first uniqueness. We want to talk about the Lipschitz condition. So now you see f of x comma y being a function dependent on its set S. This may be S is a rectangular domain, another means square, or other means some other string, right? In R2, we say that f satisfies the Lipschitz condition in y only, not x. On the set S, if there exists a constant k greater than 0, such that this condition f of x comma y1 becomes only f of 2y, right? F of x comma y1 minus f of x comma y2 less than or equal to absolute value of y1 minus y2. So this part on x comma y1 and x comma y2 in S because S is R2. The constant this k is called a Lipschitz condition. So whenever the f is satisfied condition, we can say the given function satisfies the Lipschitz condition. So the second one, this that we can read it like this also. This is the condition means the function is also true. So we the function is dependent same condition equal to only. So this we can read it like this also. Equal to only there exists a constant k greater than that absolute value of this we can relate this inequality like this. Now you want to identify this kind of k exists or not. So whenever k exists, then you can say the Lipschitz condition is satisfied or otherwise it's not satisfied. So this is a very important definition for checking uniqueness that I will tell you later why we want to check. So now the Lipschitz condition we have two kinds. The first one is a more general one. The second one is we want to apply. This is not applicable to all kind of functions, but some kind of functions is applicable. I will do some example also. So now you see, suppose S is either a rectangle. Rectangle means this denotes the rectangular domain. This denotes the string. So, and that F is a real valued function depending on S. Such that 12 by rho y exists and is continuous, and the absolute value of rho by rho y less than or equal to F for all x comma y in S. For some n greater than 0, then we can say F satisfies the condition on S with constant M. The first condition is we don't need to check first order partial derivative in this term, right? But here, first order partial derivative need to exist. So whenever that is possible, that means first order partial derivative exists and continues, we can use this condition. Suppose in case the given function is not a that means the given function not exist the first order derivative and it's not a continuation, you can use, then you can go for first definition. This definition you want to use. This is a more general one because here you don't want to check the first order derivative exists and continues, right? So now actually many places we can, but many places we can't use also. So now I am coming to the ellipsis condition. For example, I am taking f of x comma y equal to sin y. Satisfies the ellipsis condition in y in R2. So you see here, the first order partial derivative will exist because here only sin of y is a given. But also we can check that this is a cos y is the continuous function, right? So we can y can calculate. Also you can easily check if the continuous or not. So also you can see that by absolute value of y by y is greater than 20 and that is 1, right? So this is constant is 1. So therefore we can say the given function f of x comma y equal to sin y times constant m equal to 1. Sin y is the linear or non-linear, right? So sin y is a non-linear function because y is a dependent variable, right? So sin y is a linear function. So now the canonical function that is f of x comma y equal to absolute value of y that is dependent on the closed unit sphere. Closed unit sphere means that is f is given like this. That is x varying from -1 to 1, y varying from -1 to 1. Now you can use the second condition, ellipsis condition on that you want to take because absolute value of y, if you are taking the first order derivative with respect to y, not exist. So the ellipsis condition 2 is not possible to use here. You want to check the ellipsis condition 1. So ellipsis condition 2 is not a necessary condition. So you want to know which one is sufficient, which one is necessary. So this one second condition is only sufficient. Whenever first order derivative exists and continues, you can use. Otherwise, you want to use as well, and that is a usual definition, that is a first definition. So that is very important thing. So now you see that also we are explained. What fails to exist on however, that satisfies the ellipsis condition in y with ellipsis constant k equal to 1 on the region S because you see this inequality is 2, here k equal to 1. So this inequality is 2, so therefore ellipsis condition is satisfied here, right? So for second definition of the ellipsis condition is not applicable here because first order partial derivative not exist and continues. So therefore we are using this is a more general definition. First definition of the ellipsis condition is a more general definition that you want to check. So now it's a satisfied. So after that, the second theorem of ellipsis condition is not necessary because there are not functions f of x comma y that satisfy the ellipsis condition without the existence of partial derivative. So now we have a ellipsis condition, right? First we want to know because we want to check the solution is exist or not, then we want to check for that we need ellipsis condition. We have two kinds of ellipsis condition. So one is more general definition, another one is a second theorem of ellipsis condition that also though if y do y exists and continues and though if y is for all comma 1. That condition is applicable only for functions, not all kind of functions. That is the main reason. So now I'm coming to I want to check the younger problem. This kind of problem I will see as a lot of problems. So you see, so the function f of x comma y, this is a non-linear function. Y power 2 by 3 is a non-linear function, right? Y power 1 by 3 is a non-linear function. That is, I think you are already involved. So now you want to check this function is this function satisfies the richest condition on the equal domain. That is a closed sphere. Closed sphere means x square from minus 1 to 1, y will minus 1 to 1. Checking into that is R2 easily you can identify that is a closed unit sphere. It's a closed unit square, not sphere, square. So here you see, I am taking this condition first, this condition. Right? Suppose in the second condition, if you are checking y exists, not exist until y equal to 0. So therefore, I am using the first condition, that is f of x comma y minus f of x comma 0. So now you see, whenever y is closer to 0, this goes to infinity. So therefore, which is unbounded in the region because we are considering this domain, right? In this domain, y is not 0 because y varying from minus 1 to plus 1. Minus 1 to plus 1. So whenever y1 goes to 0, this goes to very long number. So therefore, this is unbounded. Common point such, right? So therefore, this condition fails. So this condition is not satisfied. This is a first definition. First definition into more general definition, right? So this condition fails. So we conclude that f does not satisfy the little condition. So now, because I will tell you the later why the little condition is important. Now suppose initial value problem, that initial value problem is not solvable. Right? Exactly the problem. Many problems. So we want to use not only we are studying probability analysis and also the numerical method. Why we want to study numerical method? Any real problem is not solvable, so therefore we are using numerical method. If or otherwise we can use stability analysis, that is called qualitative analysis, right? So here the successive approximation, because iteratively we can find the solution. So that is very important. So the same initial value problem, first order initial value problem. This initial value problem, we are taking integration with respect to x naught to x is 1. This is that we can say the differential equation are both are equal, right? So from this we can identify the first order approximation, second order, third order, etc. So whenever n is large, this coincide with the original solution. That is a procedure actually. But when we can get that whenever n is large, but all the approximation, first order, second order, nth order approximation match coincide to original solution or not, that also we want to know what conditions we require. So now here that is clear given the y not given initial condition, y1 is a first order approximation, second order, nth order approximation. If the sequence yn converges to the limit y of x, that is the original solution. Whenever n goes to infinity, the successive approximation 8 is 7. That is 8 is here. It's a, this is 8 is 7. That 7 and 6 are equal, right? If you are finding the solution for this, that solution is same as for 6 also, right? That is a procedure. Now this is a very important. Which is condition we studied, right? This is called theorem, right? So now you see f of x comma y need to be a continuous function, continuous real valued function on the rectangular domain. This is a rectangular domain, this goes. And also bounded function, let f of x comma y less than or equal to f for all x comma y in S. We are talking only in a certain domain, not entire part 2. That is one important thing. So then, suppose that f of x comma y satisfies the Lynch's condition with constant k, then the successive approximation we are calculating, right? First order, second order, etc., nth order, when converged to the original solution, whenever these conditions are satisfied. So f of x comma y need to be a continuous function and bounded, and also Lynch's condition satisfied, then we can say the successive approximation converges on the interval. This particular interval solution, what happens on the initial value problem. Also, moreover, the solution is new. So when the solution exists, first we need f of x comma y continuous and bounded on the given domain. That S is a maybe vector here. The because we are talking about the rectangular domain. Rectangular means square also will come. Whenever a not equal to x not equal to 0, y not equal to 0, that is nothing but a square, right? So for existence, we need continuity and uniqueness when we come. Additionally, the given function need to satisfy this condition. So whenever these all three conditions true, we can say the solution exists and be unique. Now I think you understood. So whenever the differential equation first order initial value problem is given, you want to check f of x comma y is a continuous function on the given rectangular domain or not, and also you want to check it's a bounded or not. If these two conditions are satisfied, you can expect at least one solution. At least one solution. But when the solution is unique, whenever the given function f of x comma y satisfies this condition. But what is the problem of this because here? That is also you want to do. This is the topic condition. That is one thing. It's not this topic condition, you know, whenever these conditions are true, you can say solution is existent. If not true, we may expect solution also and more than one solution or unique solution also we can expect. That is so this is subset only. Also, another drawback is this because you know only the existence and the uniqueness in the neighborhood of x. In the neighborhood of x, not the entire domain or two, right? That is very, very important here. I will do some examples. So now we see. Okay, so this problem is easy to solve. Right? Because it's a linear problem. But you don't want to solve because since you want to solve. But in case, if I am applying this condition, you can see f of x comma y is 2.1. 2.1 will satisfy it. So here you see dy by dx equal to 2 minus y. So f of x comma y is 2 minus y. It's in this condition satisfied, right? Because if you want to check this condition, f of x comma y1 minus f of x comma y2, this needs to be less than or equal to k into y1 minus y2. Then you want to check it. It's easy to check because it's a concept. So, but here I want to find the input existence of solution guaranteed by the because for the input value. Because here is the x minus x naught less than or equal to y minus y naught equal to that is here y naught is 1, x naught is 0, right? So x naught is 0, y naught is 1, a equal to 2, b equal to 2. Right? So that is that is here. So given the rectangular picture, this is a rectangular picture. That's very because you know more or less absolute value of x delta equal to 2, you can write it like this. So this we can write it x belongs to minus 2 comma 3. Y minus 1 less than or equal to this we can write it minus 2 less than or equal to y minus 1 less than or equal to 2. So this we can write it plus 1 less than or equal to y less than or equal to plus 1 minus 1 less than or equal to y less than or equal to 3. So this implies that y belongs to 1 minus 1. So this interval it's a given interval that is here given. Also this is bounded on this given interval, right? At what y this is you know how to find m because if you are giving minus 1, this is 3, But if you are giving 0, right? If you are giving 3, this is, 1. So at x y equal to -1, this is a larger value, right? It's a larger value. So m I calculated. Now you see alpha I want to calculate because I want to identify on which domain the solution is exists that I want to calculate. Now A is already given. You know A is 2, B equal to 2 by M is 3, 2 comma 2 by 3, but we know 2 comma 2 by 3, 2 by 3. So now you see minus 2 by 3 comma 2 by 3. Only little condition. The solution exists in the neighborhood of x naught, in the small neighborhood of x naught. But if you are calculating solution for this, I think y of x equal to 2 minus e power minus x. 2 minus e power minus x. It's a linear equation. Solution is in terms of exponential function. Solution is valid n on, not only small. So this is a, so we can talk whenever you are using Picard theorem talking only resistance and uniqueness in a small neighborhood of x naught, not entire entire. So here the solution is exist in entire R. But using Picard theorem, we can talk about only minus 2 by 3, comma 2 by 3 interval. The solution exists or not. So one thing, because there is a sufficient condition. Another thing, this is another important thing. So the given problem is a linear problem. Solution exists, and still you can find the solution in terms of the exponential function. But the solution is valid in the entire R. But however, the Picard theorem says the solution exists in the neighborhood of x. So Picard theorem is all placed in front of it. That is also you want to. So uniqueness, right? Uniqueness more that means unique solution, more than one solution, no solution. This also you want to know mostly how we can check the different secondary problem for unique solution or not that you want to know. So one example is given problem has unique solution. So this is very simple problem. Y dash equal to y. You know how to solve. It's easy to solve. You can put the solution in terms of the exponential function that is here given. But you see, y naught equal to y naught. If you are substituting here, y naught. So this has a unique solution because it satisfies here. But in case y naught equal to 0, how much solution is possible? Anyone? Y naught is 0. How many solutions is possible? Again, only one solution. It's a very simple one. But you see, this problem is actually you can easily understand, but if you have no, you want to ask. Then next, this problem, I will take the same problem. So in this problem, you want to take the solution is possible because these kind of questions, many questions are available in your CSR game also. You can check. So y dash equal to 2 to y, right? 2 to y. Y of 0 equal to 1. Here minus 1. So y dash equal to 2 to y. This is y of 1 equal to 0. Now, the problem is same. I consider this is the first problem. This is the second problem. The problem is same, but initial condition will be different. Because of initial condition only, we can say the solution exists or that this solution is unique or no solution, etc. Now, if you have this is called the separable method. Separable method. This is a non-linear mode, right? Non-linear first order mode. Then on the initial condition. The initial condition is y of not equal to y of 0 equal to minus 1. This is a good one. So it's easy to solve. So now, if you are solving, you can x plus d. Y of x equal to we can write plus or minus x plus d. Now, the c is an arbitrary constant that you want to calculate, you want to find from the initial condition. Now, I am substituting this y naught. So, y of 0, that is y of 0 equal to minus 1, that is plus or minus, this is square element, sorry, square element. Now, I am taking square on both sides. Square on both sides to give plus, right? So, now minus 1 plus or minus, sorry, here minus 1, so I want to substitute minus 1, right? So, how you can write the, if you are calculating the, you will get the complex constant. Complex constant but given anything here with the value constant. So you can't write the y as a complex solution. So here is no solution. For this x equal to 0, y of 0 minus 1, then x equal to root minus 1, which is a complex number. Thus, we conclude that the differential problem does not have any solution. But the same problem I am considering with different initial condition, y of 1 to 0. Now, you check what you will get. So, this is same solution you will get, but initial condition is different. Like y of 1 to 0, if you are substituting, you will get 0, then s plus 1, sorry, 1, 2 plus 1 whole square, that is
அழுவிருச்சுன்னா
now, complete solution of problem anyone see you to identify, right? Now, solution y of x equal to x minus 1 whole square. How many solutions is possible for this problem? Anyone? Unique or more than one solution? How you are telling more than one solution? Huh? Now, you identify C exactly, right? That is equal to minus 1. Minus 1 and plus 1. Minus 1. Okay. So now, how many solutions is possible? How more than one solution? That is my question. Because here, things you want to check. Right now, this y naught is 0. This y naught is 0. You have to check. That is here, like this, right? Why not? This whenever y naught is 0, you want to check trivial solution. Trivial solution is possible, you want to check non-trivial. This is called non-trivial solution, right? Next to any solution, you can now you see, this is also solution. Say this is a solution. Whenever this being satisfied, the given differentiation and the initial condition. So both can satisfy. You substitute the value problem. Means in initial condition also in differentiation substitute. This you will get, although this also will satisfy. So here more than one solution is possible. This is an example. But say this problem has no solution. This problem has more than one solution. Same differential equation, only initial condition is different. So whenever the initial conditions are important, it's a problem. The solution exists, solution not exists. So we study one. Form. Now, you substitute the initial condition to identify C. Can you identify what C you are getting? Y of x equal to Cx plus 1. But initial condition is y of 0 equal to 1. Now you substitute here 1, here 1. You can't find C. Now what you can say is C is any or any constant. So now by using C, you will get one solution. So you will get different number of solutions, right? That means what I am telling you can take in suppose we have what is the initial condition? 0, 1. 0, 1 means you know material 0, 1. Okay? So passing through rows of solutions. All the solutions then all the function passing through 0, y of x equal to dx plus 2. So this is the example. You have the solution. You can't find C using the initial condition. C is a constant. For every C, you will get solution. So C is real number, right? So in uncountable number of solutions you will get. That means these are really different number of solutions. Do you have any doubt on questions? Any doubt on questions? Okay. So this is actually in the CSR June 2013 question. So you see this kind of problem already. B is equal to x power y power 1 by 3 y of 0. But if you are checking this kind of problem already we have discussed. That here this is actually y power 2 by 3. But here x power x into y power 1 by 3. But if you are checking now, Lipschitz condition won't satisfy. Also, already I told you, whenever y naught is 0, you want to check trivial solution is possible or not. If you are checking the non-trivial solutions are possible. So the first option is true. First option is true. I want to explain the first option. And you understood. Okay, I will explain. So here you see f of x comma y1 minus f of x comma y I'm taking 0. This is absolute value. Right? So we have y1 minus 0. Thus, if you are taking what we want to know, here x into y power 1 by 3 minus divided by y1. This is y1. Y1 2 by 3. This goes to infinity. As y1 goes to 3. So this is condition is not satisfied. You can't find such case. So therefore, this is given as not 1.0. This is not possible. And because things are sufficient condition, not necessary. But if it is not satisfied because they have conditions now, you can expect solution. The solution also possible. But this is already 1.0. Right? Trivial solution is possible. Y of x equal to 0, if you are taking, that will satisfy. You have to satisfy. Solution is possible. If you are using separation, variable separable method, you will get non-trivial solution. So more than one solution is possible. So this is true. This is not true. This is not true. 4 is true. This is not 1.75 marks. It's very easy. 1 and 4 are answers. You have any doubt? Then next, this is very simple question. Simple one. Y of x equal to dy by dx. Then you can rewrite that way. 1 square. So you want to calculate, right? If you are then 1 power minus 1, we have divided by minus 1 and plus d, then 1 by y, sorry, 1 equal to minus 1 by x plus d. Now we want to calculate using this initial condition C. So what we will do? If you are substituting here, 1 equal to minus 1 by C equal to minus 1. So 1 of x equal to 1 by 1 minus x, right? Is it correct? 1 minus x. Now you see The solution is valid for entire real life except that's the code. So when you check it here one here involved, here one involved, here no. Right? So this is very simple question. This also similar questions. Then you have really know from this because of the one the solution is not fair. So therefore you want to check the interval where one involved. So three options, one involved, one option, one is not involved. So this is already been discussed. So this is the it's true because this is already discussed here. Zero, right? Sorry, minus one. Example we discussed. Whenever a equal to zero, you know, this has a individual solution, but any solution is not possible whenever a less than zero. That means minus one. This has no solution. This is already solved the problem. And here greater than zero, we will get some solution. But here no solution is given. Infinitely many solutions. This is true. Unique solution is not possible whenever here greater than equal to zero. That is because whenever here equal to zero, you will get solutions. That is very important. So the answer is 3 more. You will get no questions. So this all the problems. This is the problem. This is easy. You can check because here considering ordinary differential equation and all dy by dx equal to this is a non-linear. If only the function f is an even function and one is an odd function, then which of the following is correct? This is easy to verify. So if you are substituting this into the given equation, again you are getting same equation now, that is a solution, otherwise it's not a solution. Now you substitute here, one is an odd function, you know, y of minus x is minus 1. Right? So that that's what we are substituting here, left side and right side, that is satisfied. So the first one is the solution, the next one. This is our odd function, right? This is the odd function. So one is 1 minus if you are substituting. This is the even function. So if you minus dy by dx income, right side f of minus income, that is now the equation. So the second is not satisfied. The third is if you substitute here minus dy by dx income, the right side f is the even function, but this f y is not. So third also it won't satisfy. The fourth also similarly we can check using the check code. That means using the level we can easily check. So first only solution for the given you want to substitute into given differential equation. You are getting the same equation now. That is a solution because f is any ordinary function, that is given function, y is a odd function. No more questions. Okay. So the answer is 1. So like this. So using the initial condition, you can find the constant, right? The constant is you can find out that it depends on the mechanism discuss. So next, the important thing is this is also very easy one because from this area they are asking repeatedly many questions. Existent uniqueness and another one is a rank scale. Rank scale is very easy. Easily you can understand also. Only little bit you want to think. definition, you can't use all the places. We need some results, right? Results are easily applicable to many kind of problems. So that's what we are expecting results or theorems. Definition is not applicable all the places because sometimes complicated functions are given. It's not easy to check, right? So that's something. So here the ranks can have two differentiable functions x1 and x2 dependent on, and this function that is w that you know x1 of t, x2 of t, the derivative. So whenever the given function is first order, that means continuously differentiable function we can use. So that this is actually here two things are very important. In function space, rank scan is different. Solution space, rank scan is different. Function space means any kind of function, set of all functions. The rank scan is if then condition will come. Whenever the solution space, if you are checking, particularly solution of the differential equation, if and only if will come. Converse part also true. That I will explain. Because in linear, you use rank scan concept, right? That is if then concept. But in differential equation, if you are using rank scan concept, that is if and only if concept. Because function space is a bigger space, the solution space is a smaller space. The smaller space you are talking and if and only if bigger space if then condition. So that is here often if then function space. So you are taking any two functions. How to set linear independent, that is we are doing. So with the rank of two functions on I is non-zero, at least one point. At least one single point, the rank scan is non-zero, then the two functions are linearly independent. This is for function space, not a solution of the differential equation. So that is one. This is that is you know linearly independent. Suppose if any two functions are linearly independent, then rank scan is zero. Here also use that. Not only if so here we are talking about n of the any functions. That means function space we are talking. So here what we will check using two functions x1 and x2 of the which are differentiable on the line are linearly independent, then the rank scan is equal to zero. But inverse is not, converse is not true. This is for function space. So similarly, we can talk about n functions are given. How to check the linearly independent? Suppose if rank scan is not zero, rank scan of n functions is not zero, at least one point, you can say that n functions are linearly independent. If rank scan is the given n functions are linearly independent, then rank scan is zero. That is here again explained. But here why the converse is not true, that is here. If this to be noted now, the converse of the first theorem is not true general. Two or more functions can be linearly independent in an interval and yet their rank scan will be identical. For example, this is t square and the other function is p into mod t. So these two functions are linearly independent or independent. T square, t is differentiable functions are not. Mod t is not differentiable function and t equal to 0. Right? What about t into mod t? Anyone? Okay. So you see, t square behavior is like this. Mod, what is the behavior? That behavior is will come like this. You study one means suppose two functions are given. One is linear combination of another one. You can say it's a linear independent. Here even you can't write like this also because plus or minus 1 will come. Also, this the result is true, not true. That means that two given functions are linearly independent, but however rank scan is. So because the converse form is not true intent. That is a reason. So now you see these are the differential equation solutions because I want to complete quickly. So just like overview, it's a very easy to solve the problems using rank scan concept. So now you see that y1 and y2 are the two linearly independent solutions of the given equation. That is the second order homogeneous equation. So now the answer of so this concept if you have easily you can attempt many questions. So now suppose in getting linearly dependent now, suppose that the two given functions are linearly dependent, then Wronskian is 0 and n that is very important. Now you see, these are the things are question. It's a fraction of second independence. You see, this is the second order module, but we don't know the other function P of t, Q of t, and we have given P and Q complete functions, and the two functions you want to do over to these coordinates. Here you don't need to check what's the solution, what times here. Fraction of second you can answer. How? Because such that the rank can be two linearly independent solutions, ranks can number 0. Suppose linearly independent ranks can be 0 at the end of the interval, right? Here you check at some point the ranks can be 0 because t equals 1 by 2 ranks can be 0. This is not possible for rank cannot solution of different situation. Because at one point number 0. This is the wrong answer. The second one is when t equal to 0, what happens? Signs plus 0. One single point is a 0, another point not 0, right? So this is also not possible. Third, you see third answer is equal, but fourth one is the answer because neither 0 and 0. So either 0 or never 0. That is only concept. So I didn't solve. So this is a reason. So now this here also the second order differential equation two solutions are given. That which one is true? This is 4.75 marks. But how W of t equal to 0 this is the wrong. W of t is the constant. It changes negative to positive. You get one place. W of t is 0. Second is not possible. So at some point you want to end point when it can 0. The last one is not true. Only the option is 3. So you don't want to solve given equation. This equation even you can't solve it. Right? So now only this here, these are 4.75 marks. You think that given u1 of 0, u2 of 0 equal to 0 is 0. What you can say? Two solutions, different solutions, but two solutions at same point it's 0, that is a dependent solution. Even if you are calculating Wronskian at 0, you will get 0. At single point it's a 0, entire Wronskian 0. Right? So what this is the linear dependent solution, and then two of the insides. That again you can answer. So you want to know the difference between Wronskian function space, Wronskian or solutions of the differential equation. So similarly, here you see Wronskian at single point you can calculate the entire point. This is called the A-Woods formula. A-Woods formula available in Wronskian depends on this A-Woods formula. Lot of questions are available at single point. You know the Wronskian. You can write the entire Wronskian. That is clear given. Actually, here you are reduced given, right? This is called A-Woods formula. So at single point x0, if you know the Wronskian, I can write the entire x. Entire x. This is a very important formula. So when you use this, because I don't have time, I want to complete quickly. So if you are using the A-Woods formula, because you can find the Wronskian at 0. So you can identify the entire Wronskian. Then after that, you want to substitute 2, you will get the option 3. That is a A-Woods formula. Here you want to use that. This also it's a very easy one because here you want to use A-Woods formula because the answer. easily you can actually point you can calculate. Then entire because this question, if you solving this differential equation is impossible, you can't solve, you can't identify solutions also. So you want to know theoretically where different solutions are possible, more than one solutions are possible. That kind you want to know. So single point you can calculate, entire length you can calculate, and x equal to 5 easily you can calculate. So here also they will solve. These are 4.75 marks. So here also the same concept. So y of 0 equal to 0. Y of 0 equal to 0. This is a second order differential equation. Y of x is a general solution. When you can make the general solution, linear combination of two linear independent solutions. But y of 0 is 0 now. Two solutions also 0 active x equal to 0. So therefore, if you are calculating single point rank scale, that's 0. So entire rank scale is 0. So that one is 2, then 1 is 2. So that is 1. That's the same concept. So these are next maybe actually I will PDD, but PDD don't have time. So only the existence and the rank scan. If you are checking any question paper in GATE exam or CSE or NET, only suppose you know the problem solving approach, easily you can answer, because this whenever you are going interview in academic level, the maybe assistant professor or PhD interview or somewhere if you are going now, you can expect some question from existence and uniqueness. These are very basics. So when the solution will exist, when the solution is unique, the Picard's theorem is a sufficient condition or necessary condition. These things you want to know clearly. If you know these things clearly, easily you can answer any question. Because whenever ODE if you are taking, it will take time to solve, right? Here we don't need a fraction of second, we can answer only if you have some logic. So because this is possible or not. Because if you are solving the problem now, this will take maybe 1 hour, right? We can solve only 3 problems in entire 3 hours coming to exams. So at least you try to solve some, because whenever you are studying the semester courses at the time, at least individually you want to try to solve some questions, you will get some idea. It's a very easy one, because here problem solving is very important. Thinking is little bit important. So if you know these things, easily you can qualify any competitive exams. So ODE and repeating also, you want to understand the application to advanced level also. So PG, at least existence, uniqueness, and so PG level concept you want to know. If you are attending PRB or any other exams, easily you can qualify. That is best. You must say any questions or doubts, please ask. Any doubts or questions? At least you want to try. Right? First you want to try to attend some GATE exams, then you will get an idea. That you need to go. Because once upon a time, I also did those exams to get clear idea. Right? So that is depends on our effort, maybe easily get qualified. Okay, any questions or doubts? No doubts, no questions. That's the idea right? So that
I hope the session very helpful for you for preparing CSER, GATE and SET examinations, because our explain or give more many ideas for solving problems quickly in the exam point of view. On behalf of the Department of Mathematics, I thank Dr. Prakash who come out here for their efficiency. Thank you.
Thank you so much, sir. Thank you so much for all the teachers and colleagues, so faculty members. Thank you so much. Thank you for the teaching.
Thank you, sir. Lunch is time to review your recharge and rebrief. Lunch can be provided in our department. Please make sure to be back here sharply at 2 p.m.